Hello DP11 students. We have solved a quadratic equation by using three different methods in 1A, and then we have investigated the quadratic formula in details in 1B. In this new lesson 1C, we will shift our focus from quadratic equations to quadratic functions. The first question is, what is a quadratic function? A quadratic function is defined as having an equation with the highest degree 2. A quadratic function can be written as y equals ax squared plus bx plus c. You can see a trinomial on the right side, and this form is also called the general form of a quadratic function. In this form, a, b, c are constants, and a cannot be 0. If a is 0, the second degree term will disappear. Therefore, a has to be a non-zero real number in order to keep the highest degree 2 in this equation. Right now, we have 5 different functions. Among those 5 functions, not all of the functions are quadratic functions. So right now, we need to determine which of the following are quadratic functions. Let's look at the first one in A. Y equals x squared minus 6. Is this one a quadratic function? Yes, it is. Some students may ask, the quadratic function should look like y equals ax squared plus bx plus c. We should have 3 terms on the right side. Right now, you only have 2 terms. So 2 terms is totally fine for a quadratic function. If we go back to look at this quadratic function, we only can have a, which is non-zero number. As to b and c, one of them or both of the values can be 0. In this case, your b is 0. This reason, 3 terms become 2 terms. And y equals x squared minus 6 fits the definition of a quadratic function. Therefore, this is a quadratic function. Right now, let's look at the function in b. Is this one a quadratic function? Let's go back to the quadratic function model. Can we have a square root on the variable x? It doesn't look like that we can have a square root for x. So this is not a quadratic function. Let's look at c. Is this one a quadratic function? We look at the original equation model. We cannot have x in the denominator. However, this x occurs in the denominator. Therefore, this is not a quadratic equation either. Let's look at d. Is this one a quadratic function? Some of the students probably will say no. However, this one is a quadratic function. If we expand the perfect square, we can have t squared minus 2t plus 1 plus 5. We can distribute the 2 into the brackets and get 2t squared minus 4t plus 2, then plus 5. We also can combine the like terms in order to get 2t squared minus 4t plus 7. After we expand the perfect square and distribute the 2 into the brackets and combine the like terms, we can turn this equation into y equals ax squared plus bx plus c. This reason why we say this one is a quadratic function, even though it's written in a different form. How about the last one in E? Is this one a quadratic function? Yes, it is. Why? If we expand the binomial times by the second binomial, we can use the FOIL way to expand the product. We can have 2x squared minus 12x plus 5x minus 30. Then we combine the like terms to get 2x squared minus 7x minus 30, which is the same as the form in the definition. So this is also a quadratic function. So the next step is we need to work in group to finish the investigation here. So we will investigate the characteristics of quadratic functions with your group members. I will show you how to work on the first one. Y equals x squared, both manually and technologically. You are expected to complete the rest of the examples and draw your conclusions in Summary 1 and Summary 2 with your group members. We will use the most fundamental method to graph a function that we are not familiar with. Y equals x squared. This is a quadratic function with one term, where b and c are zeros. In the table of values, we pick up some x values first. Here, we have all the x values, like -3, -2, -1, 0, 1, 2, 3. We can calculate the corresponding y values for each individual x value. When x is -3, y is 9. X is -2, y is 4. X is -1, y is 1. X is 0, y is 0. X is 1, y is 1. X is 2, y is 4. X is 3, y is 9. Then we plot all those 7 points on the coordinate system. Let's start with the middle one, 0, 0. Then -1, 1. +1, 1. -2, 4. +2, 4. -3, 9. We need to go beyond the table. It's okay. You can estimate the grids outside of the table a little bit. So then 3, 9. It's around here. After I plot those 7 points, you will see these 2 points are symmetrical about the y-axis. This pair of the points are reflected in the y-axis. And these 2 points are symmetrical about the y-axis as well. So we join the points by using smooth curve. So that's the shape we can get for this quadratic function, y equals x squared. And this graph is called a parabola. Parabola is the graph for all quadratic functions. This parabola opens upward. We look at the opening. It opens up. For this parabola, there is a lowest point we call vertex. So here we can fill up vertex coordinates as 0, 0. We just talked about the symmetrical feature between 2 points which have the same y coordinates. So you will see the left side of the parabola and the right side of the parabola. These 2 parts are symmetrical about a line. And this vertical line is called the axis of symmetry. So the axis of symmetry is x equals 0. This is the equation for a vertical line. We also have the x-intercepts. X-intercept is where the graph can intersect the x-axis. Therefore, the x-intercept point is 0, 0. Y-intercept. Y-intercept is where the graph intersects the y-axis. The y-intercept point is 0, 0 again. If we look at this graph, you will see both of the ends can go up forever. This one means your x can go all the way to the negative infinity and positive infinity. Therefore, the domain for the quadratic function is x can be all real numbers. Let's look at the range. All the y values on the graph have to be greater than or equal to 0. Since this parabola opens upward and this vertex is the lowest point, therefore this quadratic function has the minimum value 0. We also can use the graphing calculator to help us check our graph. Let's look at how we can use the graphing calc to graph y equals x squared. Let's turn on the graphing calculator. If there's some graph in the function screen, let's clear them off by pressing clear button. We also need to clear the second one. For y1, let's put x squared in. So where can you find x? So the x is on this key right beside the green button. Here is the square key. Then make sure you can set up the window setting nicely. Usually we can go with the default setting. So the default setting for x minimum is -10 and the x maximum is +10. So this one means the scale length. What is the scale step you want to use on the x-axis? Like our graph, on the paper we use one little square represents 1. So we want to say the scale length is 1 here. And this scale length is 1. So we want to keep this value. So the y minimum usually is -10 as well. And the y maximum is 10. And we want to keep 1 as the scale length for the y-axis. So right now, let's graph y equals x squared. So here we go. This one is exactly the same as what we graphed manually.